Hey, Mr. Hong here, fresh out the shower and ready to teach 2-2. And before I talk about 2-2, I want to talk about what we learned before. So in 2-1, we learned how to solve absolute value equations, which the steps were like, hold on. The steps were one, um, get absolute value alone. Step two was to make a positive and negative version, and this was the step to get rid of the absolute value. Yeah, to get the absolute value, like to get rid of it, you had to make a positive and negative version of like the thing that's not in the absolute value. Like for example, absolute value of 2x is equal to 4. I would do 2x is equal to positive 4, 2x is equal to negative 4. So that's the example of what we did for to make a positive and negative version. Because I made a positive and negative version of this 4. And step 3, solve for x. Sorry, I thought I was going to sneeze. So we're talking about today, 2-2 is talking about solving absolute value inequalities. And before we go over how to do that, we have to talk about inequalities in the first place. Like, for example, if I say like x plus 2 is greater than 4, we know that this symbol right here, we treat it as an equal sign. As in, if I have, well, if I take the same thing, right, I would just subtract 2 on both sides, and this is greater than 2. I would treat this sign as an equal sign. And that's for all inequalities. So greater than or equal to, less than or equal to. All of these you treat, instead of writing it again, I will just draw another arrow. We treat it as an equal sign. So, Mr. Hong, what are we really learning today then? Because we already learned how to solve it. We just replaced the equal sign. There's going to be some rules that are going to be a little bit different. So 2-2 is very similar to 2-1. So students will be able to evaluate absolute value functions with inequalities. And of course, we have to start with a definition first. I have to define key things for me to be able to use them later in the unit, or later in the section of this unit. All right. The distance from x to 0 is less than a units. This is the absolute value of x, and oh, my pencil's so fat. I'll make it 5. So this part right here is absolute value of x, because we already defined this in 1-1. And this green color that I kind of like is less than a units, is like so, is less than a units. And what this looks like is, we know that for sure that we have to make a positive and negative version. But look what happens to my equation. So let's say that x is in the middle, like so. And we already know that this is a positive version, as in if I, since my x has got no absolute values, I have to make a positive version, and I know I have to make a negative version. But how do I know how my inequality faces? When it's less than, we're going to say that negative a is greater than or is less than x, but x is less than the positive version of a. And the in a number line, it's going to look like so. And we're going to use open circles because we're talking about we don't have an equal sign. This also applies for negative a is less than or equal to x is less than or equal to a. So both of these are the same thing, pretty much. They're the same rules, but the only thing that's different is that one is closed circles. This is closed circles. And this is, I guess I should do this. And this one is open circles, like so. Okay, that's one situation that we have, right? Or like that's half of the solution or half of the situations. Because if it's less than, the only other way, because we went over equal to and we went over less than. So the last one is greater than. So the distance from x to 0, which is defined as the absolute value of x, which is from here to here, is, I want to use this like this, nice creamy red color, is greater than a, like so. But what if I wanted to get rid of the absolute value because we can't really do much of it when it's in the absolute value form, but I can do something to this formula to make it, you know, just x by itself. And I can do that by splitting it into a positive and negative version. So the positive version will be x is greater than a. That's true. Because I just copy and pasted it and my absolute value is gone and this is my positive version. But what about my opposite or my negative version? We would have to actually flip the sign and we make this negative a. And it's going to make a lot of sense when I talk about the number line. So when I talk about this number line, like so, and I have a and negative a, if you refer to the x is less than a, or absolute value of x is less than a, we talked about the middle being what is the solution. But in this situation, the solution is actually the outside. And let me do an example problem for this one because this one's probably the more confusing one. Like, let's say, for example, absolute value of 2 is greater than a. That means that 2 has to be greater than a, and actually, hold on. Absolute value of x is greater than 2. All right, there we go. So x has to be greater than 2. X has to be less than negative 2. So if x has to be greater than 2, if this is 2 right here, then it has to be 3, 5, 17, whatever. But if x has to be less than negative 2, it has to be like negative 4, negative 10, negative infinity, whatever. So this is why our inequality behaves like so, because we have to talk about the outside of our barriers, which is negative a and a. So solving for absolute value inequalities is pretty much the exact same as the unit before, but there's one extra step, and we already talked about it. But let's do this problem, and whenever we get to like that difference, I'll highlight it. What is the solution of absolute value of 2x minus 1 if it's less than 5? Graph the solution. So step 1 is to obviously, like I told you before, get absolute value alone. And is that true? Is there anything to the left of it, and is there anything to the right of it? No. So it is alone. So this step is done. Step 2, we're going to make a positive and negative version. But you see how like my inequality is facing towards the 5? Which one was facing towards the A? Oh, this one. And look what we did with our inequality. I can make it into two, like this, or I can just say negative A is less than X and X is less than A. So I can split them into two pieces. And I'm going to actually make it into one statement. Sorry. Man, after my shower, my body's all weird. But let's try it out. So 2x minus 1. I know that step 2 is talking about getting rid of my absolute value symbol, so I did. I'm going to make a positive version of my 5. And you see how like the inequalities, like in my green and my black, they look exactly the same. They're facing the exact same direction. The alligator is facing towards the right side. So my alligators, like my Pac-Man, is facing towards the right, and I'm just going to make a negative 5, or a negative version of my solution. Okay, so if I add 1 here to get rid of everything else, right? Because my third step is to get x alone. That means I have to add 5 here, or 1 here, sorry. I have to add 1 here. But what about this one? I actually have to add 1 on this one too. So really, I'm doing the same operations. I'm just writing it more efficiently, like in the same piece of paper so that I can save paper. So this goes away, right? My inequalities go down. This 2x I haven't touched yet. Okay, 5 plus 1 is 6. Negative 5 plus 1 is negative 4. So if that rule applies to everything, or like if I did a one operation in the middle, I have to do it to the like both the left and the right side. So if I have to divide by 2 here, I have to divide by 2 on both my left and my right side of the inequalities. So I ran out of space here, so it will be negative 2 is less than x is less than 3. Nice. And this is actually the final answer because I know this is my final answer. This is my final answer because x is alone. And what this statement is saying is that if I draw a number line, I'm saying that negative 2 and 3, right here, I'm saying my solution is somewhere here. Between these numbers, I can plug in for x, and it would make my solution correct. And I'll prove it to you this one time just so that I don't have to do it again later. So 2 times 0, because 0 is between negative 2 and 3. It's like such an easy number to multiply with because anything times 0 is 0. So 2 times 0 uh, minus 1 is less than 5. So let's see. 2 times 0 is 0. Minus 1 is negative 1 is less than 5. Like the absolute value of negative 1. That's 1 is less than 5. That statement is true. So I just proved this is how you check your answer. I just took an answer in my red area, or a solution in my red area, and I just plugged it in. So let's look at this one. What is the solution of absolute value of 3x minus 4 is less than or equal to 8? I told you that this sign, even if it's less than or equal to, we treat it the exact same way. So step 1, absolute value. Is the absolute value alone? Is there anything to the left of it or to the right of it in the same side of the equals, or yeah, on the same side of the equation? Yes. So we're good. Step 2, plus or minus, or we're going to make a positive and negative version. So I'm going to do this. 3x minus 4, and if it's less than or equal to, I use like the symbol like in the same direction. So I will do the same. And do not forget the equal to, because this has an equal to, so I wrote my equal to's. 8 and negative 8. I made my positive and my negative version. As in this right here became positive and negative. Okay. If I do the same application as I did my last problem, I can add 4 in the middle, but that means that I would have to add 4 on both the left and the right. Mr. Hong doesn't know his left and the right apparently, even though he is left-handed. So adding 4 gets rid of the 3, or the adding 4 gets rid of the negative 4, so 3x is left. This comes down, and that comes down. Oh, obviously the 3 came down. Okay, so 8 plus 4 is 12, and negative 8 plus 4 is negative 4. And now, my last step is to divide by 3. Oh, this is step 3. Get x alone. So, dividing by 3 gets my x alone. So, pretty much my answer right here will be my final answer, right? Because I stated earlier that this is my final answer because x is alone. This step right here, dividing by 3, gets my x alone. So, I have to divide. I can't divide for free. I have to do it to the left and to the right because I have two equal signs. So 12 divided by 3 is 4, but negative 4 over 3 is an ugly number, and I want you just to write it like this for now. Negative 4 over 3. It's gonna, you leave this as a fraction for now. In pre-cal, you'll learn why you do something else, but we leave it like this now because it's nice and neat, and we're not going to really put this into the calculator as often. All right, so we know that this is my final answer because x is alone. Let's try to graph this. And it's not on like a graph like this, like a plot point graph. It is not like this. Graphing it for absolute value for now, like when we're solving it, is talking about a number line or just the x-axis or just the y-axis, because if you know, these axes are just number lines just going up and down and left and right. But I want to talk about a number line. What I'm saying is if this is 4 and this is negative 4 over 3, my solution has to be in the middle again, which is here. But this time I have to draw a closed circle because I have to include it because it is equal to or less than. And let's say Mr. Hong, I'm not sure. Okay, let's choose a number between these two like barriers or like my solutions. Like for example, 0, because 0 is between negative 4 over 3 and 4. So let's plug it in. 3 times 0 minus 4, and take the absolute value of that, is less than or equal to 8. That means that the absolute value of 0 minus 4, which is the absolute value of negative 4, has to be less than or equal to 8. Is that true or false? Because this turns into 4 is less than or equal to 8. That statement is true. So this is correct. So in conclusion, like these two problems, we're doing the same exact steps, but the last step is talking about just drawing a number line just to make sure, and then to check your answer. So like I checked at 0 where my answers for both of these because they're in between -2 and 3. So let's look at solving absolute value inequalities when absolute value of A is greater than B. So what is the solution of the absolute value of 5x plus 10 is greater than 15? The steps are really the same, as in get absolute value alone. This is not a B. That looks like, oh my god. Whatever, you know what that is. And is there anything to the left? Is there anything to the right? No. So my absolute value is the most outside thing on the left side of the equation, or whatever side of the equation it is. So this is true. Step 2. We're going to make a positive and negative version of this number right here. The other side. Ah. Okay. So 5x plus 10 is greater than 15. I know for sure that this is my thing for because this statement is a positive version of this. But when A is greater than B, when A is greater than B, or when the absolute value of a number is greater than like your number or whatever, the negative version, the greater than symbol the mouth, like the inequality is gonna face towards that negative version. So let's take that to heart. So I'm gonna make a negative version, and I'm gonna take the inequality and face it towards it. 5x plus 10. And not like the other inequality version, like less than. We cannot combine these two statements. Well, you could, but it would be ugly. So it's just easier for us to keep it separate. So minus 10, 5x is greater than 5 divided by 5. X is greater than 1. I subtract 10 again. 5x is greater or less than negative 25 divided by 5. X is less than negative 5. If you notice, I I took the same steps for both of these at the same time. Like this step 1 was to subtract 10, right? And this step was to divide 5. So the reason why I combined all of those statements from before, like in these questions, is because I know that I'm gonna have to do the same operation in order because I'm talking about the same like equation inside my absolute value for both of my answers. So I'm allowed to combine those statements. But like with this, I still can, but my inequalities like be facing weirdly, and it doesn't really seem appropriate for me as a teacher to teach you that. Oh, we already did step 3. Get x alone. Okay, but is that statement true? Let's try it out. So let's draw the number line first, which is right here. And this would be 1, and this would be negative 5. And x is greater than 1. So x is greater than 1, like this. This is an open circle. And this is an open circle too. X is less than negative 5. So I just have to choose one random number within these red lines, and I only have to choose one of them. And I'm going to choose an easy number. I'm going to choose 10 because 10 is pretty much multiplying by 1, but just with a 0. So if I choose 10 as my way to check my answer, absolute value of 5 times 10 plus 10 is greater than 15. 5 times 10 is 50 plus 10, that's 60. So absolute value of 60, that's 60, is greater than 15. That statement is true. So this is correct. If you felt like very unsure about that, you can always check this right side too, because you can check more than one answer. You just have to make sure it's within like that boundary. Like my red line was considered my boundary of solutions. So step 4 or example 4. Without solving this problem, describe how the graph describe the graph of its solutions. So if I take the absolute value of x minus 3, it has to be greater than 2. That number, what does x have to be? X has to be anything. X has to be, well, really, x has to equal. I like this statement better. X is greater than or equal to, because if I do something minus 3, if I subtract this, what does it make it equal to? The smallest number has to be 5. Because 5 minus 3 is 2, and absolute value of 2 is 2, and this statement would be true. So it has to be greater than or equal to 5. But what if it had like a negative number? Like negative, or not negative x. Like negative 1. Negative 1 minus 3 is negative 4. So negative 4, and you take the absolute value of that, that's 4. So 4 is greater than or equal to 2. So that statement is true. What about 3 or 1? Can x be 1? As an absolute value of 1 minus 3 is less than or is greater than or equal to 2. 1 minus 3 is 2. That means that 2 is greater than or equal to 2. So 1 seems to be like the way to get it equal to. So you see how I got like my answer, like 5, was the perfect answer to make it greater than or equal to 2. It's equal, right? So this 5 became my answer. So if 1 became like the reason why these statements became equal, and I know that if I take a smaller number like 0, 0 minus 3, which is negative 3, and if I take the absolute value of that, that's 3. We're going away from our solution, but we're keeping our statement true. So that means that my x is getting smaller from 1. So x is less than or equal to 1. So it's kind of like a puzzle. It's really up to you how you want to solve these, but I would recommend doing the algebra for it because the 3 steps that I've designed or like taught you guys is like a very efficient way to make sure that all absolute value equations can work like that. You could always piece it through and like talk about like you can write down your thinking and guess and check, but guess and check usually takes too much time. Takes a lot of like number smarts or number sense. So I like the formulated steps that I've came up with. And the last part of the lecture. Sorry. Using an absolute value inequality to write a formula. or to I want to use this in real world problems or situations or whatever. So example 5. Suppose that the desirable height of a race car entering a race is 52.5 inches. The least allowable height is 52 inches and the greatest height is 53 inches. What is the absolute value inequality describing the height of race cars within the indicated tolerance? If you remember from 2.1, I wrote that x absolute value of x minus start is equal to variance. And we can take this equation and we can say that absolute value of x, which is still the same, right? This absolute value came, minus came, and the start is coming with us. But instead of this equal sign, I can change it into like any of my inequalities. And this variance is still the same. So I already know that my variance, so if I go to 53 to 52, what is the difference between those two? Like, what's the gap between them? The gap is 1. So I know my variance is 1. I don't know which sign I'm going to use yet, but I'm still going to write my absolute value, my x and my minus, and the start. The start is talking about that, like, kind of like the average or like where you should begin. So the least the least is 52 and the greatest is 53. So that's like not like the average or like the median. The median is this 52.5 or 52.5 inches. Okay, but how do I know which sign to use? Well, the best way is to guess and check, but I know that in the statement that it cannot be like within 52 or it cannot pass 52 and 53. So I already know that it has to be an equal to. And really now it's just like a 50-50 odd. So I'm just going to guess this way. And the way that we solve this is by checking. Well, first of all, we can look at our example. Oh, all of our answer choices are facing the same way. So luckily I got right. I got correct. But what if my examples or my answer choices had like two like facing inequalities? Then what do I do? You just guess and check from there. So absolute value of x minus 5 like this, and then I would just create two versions. And I would add. So if I add these, x would be less than or equal to 53.5. Absolute value of this is going to be this one's going to be absolute value of 51.5. So how much am I off? This is positive, sorry. How much am I off from this? So 53 is my max, right? Is 53 is the greatest that I can have it, but my answer became 53.5. So this amount is too much. By how much? I can tell by doing 53 or subtracting this by 53. It's too much by zero point 0.5. So my 1 isn't my answer for my variance. My variance is actually zero point 0.5. No box there. So I actually need to erase this. now that I've guessed and checked my work, which is very important in absolute value because it's very hard for you to formulate these word problems because they're confusing. Now that I've formulated my answer, I just look for one that makes the most sense, which is, oh, this one right here. C. Most people, I promise you, will choose A, like Mr. Hong, who has made a mistake in this video, but is too lazy to make a new one. But I guess it was good that it happened because you can think of this process of, oh, how come my answer is one too many or one too less? And the way to change that is to change your variance. So that's it for 2.2. We learned how to obviously work with absolute values equations with inequalities when it's greater than or less than or equal to. And we just pretty much worked on another word problem. Know that these word problems will be on your test, and so will like the like more advanced versions of like this type of problem. But you know, I hope that you watched this video. I hope you learned a lot, and I'll see you next time. Mr. Hong out.